welcome. We're going to start first with the OSH Act. Okay, I have found something that is kind of relevant to your industry. I don't know much about your industry, but I'm going to talk basically on electricity. Okay, we do have a lot of situations. I, as the inspector, go to court cases and that type of thing, fatalities, where people do get shocked, either from informal settlements or homes, or don't necessarily die from electrocution, but lose an arm and lose a leg and that type of thing. The court is very hard on transgressors, and it's all a paperwork. Paperwork and qualifications, only the wrong guy do the job. Okay, so, and while a murderer by law is innocent until proven guilty, if it's an OSH Act related injury, you are guilty first and you must prove innocence. Okay, so the law doesn't really favor people that when it comes to injuries as a result of work and poor workmanship. Okay, and the first thing that attorneys work on is the OSH Act. The OSH Act is enacted, and by that, that's what's in the OSH Act is what you get prosecuted by. Okay. The one that I found relevant for you guys is the driven machinery regulations. No user may use or permit the use of refrigeration or air conditioning installation unless it complies with a safety standard with respect to its construction, installation, operation, inspection incorporated for this purpose in these regulations under Section 44 of the Act. Okay. You guys know more about that. Basically, it's saying that you must make sure you're doing your work properly. I don't know much about refrigeration, okay, except to say that if you are doing it, it needs to be done properly, correct standards must be followed. Okay, that's all I found that was relevant for you guys. The next one is electrical installation regulations. Okay, first of all, electrical contractor. An electrical contractor is any person that is registered with the Department of Labor. You must register as an electrical contractor with the Department of Labor to be able to do any electrical work. Okay? And also it goes further on to say that an electrical contractor is somebody that employs somebody in a full-time capacity that is registered or is himself a registered person. So you can't just go do electrical work without employing somebody that is registered or yourself being registered. Okay, and then there's different classifications of registration. Of an electrician, you have a single-phase tester. His job would be to inspect, test, verify the construction of electrical installation where the point of control is single-phase, except hazardous areas. An installation electrician, inspect, test, verify the construction of electrical installation where the point of control is three-phase, except hazardous areas. And then a master installation electrician can inspect any installation. Okay, that's all from the electrical installation regulations. A single-phase tester is a guy that has a blue card. As by definition, he inspects and tests and verifies the construction of electrical installation where the point of control is single-phase. The requirements to be a single-phase tester is almost such a joke, really, because he doesn't need almost no qualifications. So there's a problem. They don't have to do the exam, installation rules, so yet they're doing the same work as a guy that's an installation electrician. His limitations would be to single phase. An installation electrician, three-phase, except hazardous areas. And then a master, like I said, any installation, an installation electrician his card will be will be blue, and a master will be red. Okay. If a guy comes onto any premises and he does any electrical work, and you ask him for his card, I as an inspector, well, the first thing I say is, where's your card? Oh, I left it at home. As soon as they say that, alarm bells start ringing. Okay, just like everybody walks around with their driver's license, all electricians walk around with their card. Okay. General control. Okay, I wrote there, it's mandatory. Okay, what general control, which is something also that the court stress on, is general control. In other words, you can't just send somebody out and let him go do the work without general control by a registered person. Okay, general control means instruction, guidance, and supervision. You don't necessarily, a guy that's not qualified can work on your site if you feel that you can trust him, but he must work under your supervision and your guidance and some sort of control. Okay, and it goes on further to say that no work shall be undertaken without such control. So that's very important. And whenever I go to seminars at the Department of Labor, they've always stressed on general control. If an inspector from the chief inspector from the Department of Labor comes onto a site and he finds there's one registered person on the site and it's a massive site, he closes the site. Okay. Point of control. We spoke about point of control. We spoke about point of control when we described the different grades of electricians. Okay. Point of control is anywhere you can switch off, an isolator on the wall, circuit breaker, it's a point of control. These definitions are very important, especially when it comes to arguments. You need to understand where you're responsible, point of control. Point of outlet, consider a socket outlet, whether it's a three-phase or single-phase socket outlet, that is your point of outlet. Point of consumption is the termination, maybe of your aircon, where you have your L1, L2, L3, that's your point of consumption. Okay. And that point of consumption supply terminals that connects one form of energy into the other, one electrical energy into another form of into another form of energy, either cooling, heating, whatever. Okay. Then we speak about electrical certificate of compliance. A registered person can issue an electrical compliance certificate. Only a registered person. Okay. Bit risky because if you don't know how to fill it in, it is a problem. It must be filled in every detail. Okay? As soon as, if I receive from contractors and I see it's one little thing out, it's invalid. Okay, it's got to be filled in every detail. It's required for any new installation. When they do an installation, the municipality will switch on for the registered person. He must be on site, must show his card. We'll switch on for him. He tests the installation, and if there's any faults, then he will say, we'll switch off. There's picked up some problems. Okay? The problems even could be on the municipality side, but we'll get back to that side, to that part just now. Any new installation, if he feels he's happy, no wires still hanging in. We can't do every inspection. If you do a random inspection and you find the guy's asked for a service and there's still cables hanging, we don't give it to him because he's unable to give a certificate. City of Cape Town works a bit different to our municipality, where City of Cape Town will say we want a certificate first before we put the power on. That's very wrong because what test are you going to put there? It's only your earth test, only your dead test. Okay, so we don't accept that. We put the power on, you do your test, you're happy, you give us a COC on site. Okay, we normally recommend for them just do all your tests, do your dead test, do your counts, everything else except when it comes to power. Then you can just fill that in and hand it over on site. Some guys say, well, okay, we left it in the bucket. Some guys say, no, we do it on the computer. Okay, then we'll give you a couple of hours. Okay, but we don't leave power on without a COC. All right, and it's also for any alterations to existing installations, provided that there is a COC over their property. Okay, that's also a conscientious issue where contractors will go onto a site and they'll do partial work. They'll say, no, I want to give a certificate only for the work that I've done. It doesn't work like that. Okay. The first thing a contractor must do is ask the client, do you have a certificate over the property? And they say, no. Well, then unfortunately, I've got to go through your whole property. Be it a factory as well. If you go into a factory and a guy says, no, I just want a couple of machines connected or want whatever, I need a COC, please. The right way to do it is to ask the guy, do you have a COC for the property or for the business or for the whatever it is? And they say no. As soon as they say no, well, I can't give you a COC, I can't even do the work legally. Okay, because as soon as you give a COC, you've got to give a COC for the whole thing. And that's also in the electrical installation regulations. It also says prior 1992, there were no certificates of compliance. So if you do any alteration work to that type of premises, you'll issue a certificate for the whole installation. That's how it works. Okay, some guys will say, well, the client doesn't have the money, especially if it's a big farm out in Paarl, where we are. Lots of farms, Paarl, Wellington, a lot of farms. Guys say, well, the guy doesn't have money, just we put a pump for him, and too bad. I just know the book, and that's it. Okay, so that's how it works. It is a bit tricky because people don't have money and that type of thing. There's all these issues, but it's best to stay away from it. Okay, to be a registered person, single phase tester, almost no requirements. I think you need to have N2 and 1.5 years experience. Okay, if you don't have the N2, then you need to work for somebody with 4 years, I think it is. Okay, but that's it. And then you become a single phase tester. Installation electrician, part of the, actually been having a problem with that because the type of, there must be electricians or lift mechanics. If you go on the website, you'll see. Lift mechanics can get, I don't know why air conditioning guys can't, but I mean, maybe your body can actually push it. That you guys, because there's a lot of electrical work in your field, a lot. In fact, a lift mechanics got very little, just motors up and down, that type of thing. You guys are much more electrical. So maybe SAIRAC can actually look at it and do it. But I would recommend everybody just write installation rules, paper 1 and 2, have evidence of your electrical work, take videos, take photos, and send it over to Pretoria, and they will give you a license because there's a lot of electrical work you do compared to a lift mechanic. They obviously have pushed for it so that they got it right, but air conditioning technicians, I Googled it, I looked at it properly. We have a meeting sometime end of the month. I could speak to people like Peter Loubser and Malatsi and that type of thing with the Department of Labor. Okay, we meet every 3 months, and I'll be meeting again now. I haven't received the invite yet, but it'll be sometime this month. I'll bring it up. But you as a body can also just motivate for it, because that's a problem. If you're a mechanic, if you studied mechanical engineering as well, you can get it if you got installation rules 1 and 2. You can also just maybe do N5 electrical techniques or something, some sort of electrical subject with evidence of you doing it, electrical. So it's not, while you may see that this is the path, it's not cast in stone. If you can motivate that you can do this and you can do that, they will give you a license, provided you have the same criteria as electricians. You must have some sort of electrical subject behind you. All right. Then there's also a definition of a competent person. I don't know if you've heard about competence A, B, C, and D. Competent persons have certain limitations. Okay? A guy with a trade test, maybe just a guy with a trade test. There is rumor that over and above a trade test and N3, the guy must have a wireman license to be able to be competent. That's just something that may happen. So it means an electrician that doesn't have a wireman license won't be able to really go to another level. He'll stay like just below the qualified electrician. Okay, but they also, from the last time at the Department of Labor, they did speak about changing the criteria as well, whereby when a guy is doing his learnership, part of his training is the SANS standard, like how it used to be before. And when a guy passed his trade test, he got his card. Okay, they're trying to introduce that again. Okay, that is A. B is a guy with a diploma, either electrical or mechanical, from a technicon, with at least an equivalent of N5 electrotechniques. Okay. C would be a guy that's been to university and he's got a degree. And D would be a certificated engineer. That's the guys with a government ticket, GCC. Okay. Government tickets, very interesting. You don't even need matric to have a government ticket. Okay, I know a guy that was a bit naughty. He dropped out of school standard 9, went up to N1, N2, N3, then he did part-time studies up to N6, followed the relevant subjects, and he wrote the GCC exam and he passed without his matric. Okay, so that is a part that I always said, I wish I knew that part earlier in life. You learn these things later on, but that's how life is. Okay, so you find a guy who's a certificated engineer, you know the salaries of a certificated engineer, which is a must over large kilowattage factories. You must have an engineer to take overall responsibility. Okay, that is a competent person. Other one that is not there is a consultant. Okay, what is a consultant? Any person that is registered with the Engineering Professional Act, in terms of the Act 46 of 2000. Okay, that's what a consultant is. Somebody that has registered in terms of the Engineering Professional Act 46 of 2000. Those are the consultants. Okay, are there any questions? Okay.
Yeah. You mentioned the issue of installation technicians and so on. My question is, in terms of explosive environments, there is apparently some limitation as to the qualifications an electrician should have in addition to be able to work.
He must be a MIE.
MIE being sorry?
Master Installation Electrician.
Okay, and that's enough.
Yeah, with relevant, part of it is to have the experience.
And then you can sign off.
Exactly, for explosive areas, yeah. The way to become an MIE is, there's different options, either N6, if you've got N6, or the equivalent of an N6, and with paper 1 and paper 2 in specialized codes, and relative experience, must have some sort of experience, okay, on hazardous areas. That's route A. Route B would be N3 would be fine, then with relevant experience, after having done his paper 1 and paper 2, in specialized codes, then he'll be interviewed, even if it's by Skype or go to Pretoria and get interviewed by SAFA. SAFA is a South African Flame-Proof Association, not Football Association. Okay, it's an association, SAFA. If you've got less qualifications, less than N6, they will interview you and check your competency. Can you classify zones? Do you understand EXP, EXD, and those type of things?
Because that's the other question. Your zone classification, where do I find that?
Okay, classification of zones is something, okay, over and above a compliance certificate, the normal yellow compliance certificate that you've seen, there's an additional test report for hazardous areas and medical locations. Okay, now with that, the person that will classify that area is the expert of that area. You need to speak to maybe the foreman or the manager or something. They know the environment and they'll be able to tell you this gas is explosive, this dust is explosive. They will know. You can't just walk in and say, I'm going to classify it. You can't. You need to actually speak to the people that work with the stuff. They'll help you to classify it, and they've been trained. There's a class 1, division 1, or whatever it is.
And what about going to a local fire chief?
Maybe he knows, but...
But who issues his own qualification?
No, not you as a registered person. You won't know enough of the environment. You need to speak to people that are familiar with the environment. Normally a foreman.
Yeah.
He'll be trained.
But then, does he then issue and say this area is a zone naught or a zone 1?
Yeah, he will. He will give it to you. Or even the engineer. If it's a big factory, the engineer will be able to tell you.
And then we must be qualified to work
in that zone. You would know there's different codes. 086, 089, 0108.
Now, if we don't bother about that and we're working in there and the thing goes up, then obviously we're at fault for not having established the zone.
Yeah, but if part of the MIE training is that you will know you'll know the zones. You must know the zones. If you do forget, I got my MIE in 1997 or 98. That's when I wrote. So you forget, but the books are there. You just got to read. Okay. It's not something I do every day, so I do forget. So you just got to just read. Okay. All right. It's like zones of a bathroom. Who knows the zones of a bathroom? In the bath, zone 0. Edge of the bath, 2.4 meters up, zone 1. I think it's 400 away is zone 2, and 3 meters, 2.3 meters away would be zone 3. How are you allowed to put what material in which zones? Okay, so you need to know that. Your material, nobody should sign off a job if you don't have the paperwork for whatever equipment it is in any area, especially in a hazardous area. It's very important that you know that you have the paperwork. For instance, if a guy gives you a light fitting and want to stick it up, or you go to Voltex or wherever you buy a light fitting and you want to stick it up, Flame-proof, weather-proof, looks exactly the same. You wouldn't be able to tell the difference. The only difference is that the paperwork, it'll be classified. Very little companies do it under very stringent conditions, but they do classify it and say it's EXT or it's EXP.
If you buy IP66 or 65, you just put there IP65.
IP65 is water and splash and dust and that type of thing. It's not hazardous.
So it's up to you again to get that.
The paperwork is very important. They look the same. So paperwork is important. I always had a problem. People ask me to come and inspect before I start with the municipality, inspect hazardous areas. So where's the paperwork? You know, well, it's always been the case. I said, no, I need to see paperwork, flame-proof, weather-proof. Some say, no, if you open it, then it switches off. That's not always the case. Some explosion-proof stuff stays on with a cover on. So you need the paperwork. It's important because they look the same. Okay, flame-proof, weather-proof, it's the same. Okay, but part of your training when you become an MIE is you will learn classification of zones. I don't know if you've heard recently about the exam results for installation rules. Hasn't been good. Hasn't been good. There's a new examiner, so the results haven't been good at all. I give classes in PAR for installation electricians, and the one day I inadvertently gave them a master's paper. I said, well, let's answer this, and I thought it was a paper 1 because it was slipped in there. And most of them could answer the questions. It was based on the OSH Act. So I thought, well, maybe I should stop with this installation rules and start doing masters. Seems easier. You know, the installation rules is a bit too wide, and I think the examiner is asking a bit difficult questions. But whatever he's asking is in the book. But most guys pass by following past papers. Okay. IP ratings. Everybody knows what IP ratings are? Okay. Oops, sorry. IP, let's say IP44. Okay, IP44 means, but IP rating means ingress protection. Okay. The first numerical coefficient denotes solids. The second numerical coefficient denotes liquids. Not gases, liquids. This is why I say IP ratings is simple stuff. If you look at the table, it will tell you what the penetration of this solid. Standard test finger penetration, how deep must it be before you be able to get a live part? That's not a solid. Dust, what kind of dust it is, but not combustible dust. Dust, will it be able to get in? How much dust? Will be able to get in. Liquid, the second one is liquid, is what kind of exposure it is to liquid. Is it a slight spray? Is it heavy rain? Is it going to be immersed in water permanently? There is a table that you'll be able to tell. Okay, unfortunately for the installation rules, guys, is that I always tell my students, don't worry about the table. The important thing is to know where the table is. And then you know, okay, when you go and buy a light fitting, you've got to know the environment. If it's a swimming pool DB that's outside, for instance, check it out. Is it going to be exposed to the full weather, most likely? Then you can choose maybe IP44. If you go to Voltex or wherever you're going to buy you're going to buy something that's weatherproof, the guy is going to ask you, what is the IP rating? So, well, no, give me the best. This is, well, 3,000 Rand. Whereas you could got away with a 500 enclosure. Okay, so it's very important to know your environment, to choose. And the table is there for you to go there and look the degree of splashing. Is it coming from this angle and that type of thing? Is it going to be immersed permanently in the water? So you got to know. Okay, so that's what IP rating means. Ingress protection, the first letter denotes penetration of solids. Solid is dust, generally. And the second one is liquids. Okay, flame-proof, EXD, EXP, different story. Okay, I think we've done that. And then the next one, C, is change of ownership. Okay, C would be the change of ownership. That's when you would need a COC. Change of ownership doesn't necessarily mean you're taking the property and you're selling it. Doesn't necessarily mean that. Even if you're giving it to your child as a donation, still a change of ownership. One spouse dies, they need to change it over to the next spouse. And you need a compliance certificate. Is that clear? Change of ownership is under all those conditions. Doesn't only relate to sales. As long as it's a change of ownership. Change of a business as well. Okay, next one. Responsibility of electrical installation. The responsibility of electrical installation is solely for the user or the lessor. It used to be like that. The regulations of 1992 was that. Then there was a new one, 2009, electrical installation regulations, which made a bit of changes. It says, okay, it's not necessarily just the user or the lessor. We may pass that responsibility to the lessee, but that responsibility has to be in writing. If it's just in good faith, no, my tenant can stay there, it's fine, you're still responsible. Somebody dies on the property, you're responsible. Unless you put it in writing and say, I'm transferring the responsibility of the electrical system to you. There's my compliance certificate for the building. That responsibility is now yours. If you knock down a wall, which is always the case, knock down a wall, change a fitting to suit your business, it's your problem. Okay, that's what it is. If you just say carte blanche, no, it's fine, I'll take care of it, you're actually exposing yourself to a lot of unnecessary suing and type of thing. Because it is, it used to be, 1992, it used to be the responsibility of the user or lessor. 2009, that changed. They said that responsibility could be shifted back to the lessee. Okay, but it must be in writing. Okay, then I spoke about construction regulations. I think you spoke to me earlier on about construction regulations. The parts of construction regulations that will affect you guys is temporary installations. Okay, now temporary installation, there's very strict rules with temporary installations. There's always a myth around temporary installations. It's only a temporary installation. But there's lots of laws because everybody on a construction site, for instance, on a construction site, everybody is using power from your temporary installation, not just for yourself, it's for everybody else. There's a tiler, there's a bricklayer, there's this one, there's that one. The guy, the air conditioning guy wants to test his stuff. So everybody needs this temporary power, right? All electrical installations, temporary installations must be inspected once a week by a competent person appointed in writing. All equipment that goes into those socket outlets must be also inspected, but on a daily basis. So every day you got to check the guy's drilling machine, check the cable's not frayed, the plug top is not broken. Unfortunately, it's in the book. The people will say, and it's in the act, so you have to do it. Okay. So all temporary electrical installation you must exercise general control over it, and that control must be by a competent person, and that person must be appointed in writing. All electrical equipment that gets plugged into the system must be inspected on a daily basis. Okay, until the construction site is over. SANS talks about construction and demolition sites, very similar. SANS only talks about the responsibility. SANS talks about what the DB should look like. It should be painted orange. It should be robust for site conditions. It must have earth leakage. If you've got one main DB and it's a big site and you've got different sub-DBs, those sub-DBs must be protected by at least a 500 milliamp earth leakage on construction sites. Okay. The reason why 500 milliamps is if the cable is lying on the floor, somebody picks it up, it's got some sort of protection. 20 milliamps, that argument that 20 milliamps is fine, 20 milliamps is not fine, 20 milliamps is fine for the socket outlets. The other one is fairs and faiths and jumble sales and church functions and that type of thing. There you also have temporary electrical installations. Rules are slightly, they're similar, except that the DB doesn't have to be painted orange. Yes, the DB must be there, but it doesn't have to be robust for site conditions, hard wearing. It's just for temporary, maybe for a church function or whatever it is. Again, also, the earth leakage protecting all those different cables lying all over the floor must be at least 300 milliamp. Okay, not 20 milliamps. Don't confuse yourself with 20 milliamps because that's just for the socket outlets. Okay, then we spoke about generators. Sometimes you guys need generators to test your equipment. Okay, you've heard about VOV. Has anybody heard about VOV generators? Nobody. Those little ones that you see with the wheels that you use normally on construction sites, those are called VOV generators. Okay, they are fine. They are fine for its use. Because on construction sites, most generators, most equipment that you use, that you plug into the generators are double insulated. Double insulated is normally indicated with a symbol, a square within a square. Okay, those, they don't require earth, so they're fine. But some people connect it up to their DBs at home with a changeover switch, especially during load shedding. That is a problem. If you have been guilty of doing it, which most people do, they put a nice changeover switch, LED lights, and say, well, check how nice my installation looks. And that's not allowed. Okay, it's a VOV generator. This is what a VOV generator looks like. Okay. Two equal sets of windings. Supply voltage, let's say, is 230 volts. Obviously, if they're equal, we're going to have the same voltage across there, 115, 115. If you measure between that point and that point, you're going to get 115 volts. Between that point and that point. Neutral to earth already is at a dangerous level. Okay, so you can't use them. Those generators, those are the wheels that you push around for construction sites. They're perfect for that. I've been into some shops where I've had to speak to them and tell them, don't market it in the way that you're doing, especially during load shedding. They sell it. There's a TV there, there's a fridge there, and they say you can plug it into your home. It's not allowed. I've heard how people, one guy actually died because the guy plugged the generator into the wall and it went through the transformer and onto the line while the guy was working on the line, knowing that it's dead. It became energized and the guy died because of a generator. Okay, so if you have been using those generators, just please don't use them for home. Okay. All right. Any questions? Okay. Talking about your elevated voltage between, let's say that's your live, that's your neutral. You elevate it between neutral and earth if you have to test an insulation, and your voltage is slightly elevated, whether it's an appliance, particularly fridges, deep freezers and stuff. Deep freezers, more likely because deep freezers don't have to be on earth leakage, except on events. At events, there's a Events Act, okay? And the Events Act says that all appliances must be on earth leakage. So unfortunately, if you're having an event and you got those temporary air conditioners and your deep freezers, it's only there for a little while, it must be on earth leakage. Generally in a factory or in a big shopping center, your deep freezers don't need to be on earth leakage. But that's where the problem comes in. It's not going to pick up leakage problems, and we do get people getting a tinkle from the fridge and that type of thing, or the appliance. I have a lot of call-outs for people getting shocked in taps and that type of thing. Okay. The way to test it would be to test from an incoming neutral and an external earth. Not your earth and your neutral, or your earth and your neutral in the house. It's an external earth. Knock an earth spike outside or something, and you'll find that your voltage, if it's spiked, It's at a dangerous level. Sometimes it's beyond your control. You can walk through the house and you can't find a problem. But this is what SANS says. If it's up to about 50 volts, if it's up to about 25 volts, you will notify the supplier, whether it's Eskom or the municipality, in the form of an extra H. That's found in the regulation book. Okay, you don't have to be a registered person. You can get it on the internet. No, I haven't seen it on the internet, but it's in the regulation book, an extra H. If you've got the edition 1.8, it's there as an extra K. Edition 2 is what we're working with now, so it's an extra H. Okay, you fill that in, and then you notify the municipality. And most of the time when we do go out, guys are stealing cables and they steal the earth wire from the transformer. That's why I said sometimes it's beyond your control. So you notify the municipality if your elevated voltage, elevated neutral to earth is up to 25, is about 25 volts and more. 25 volts and more. If it's 50 volts or more, you switch off the installation. Okay. Don't have to consider the person's koi and the meat that they have, switch off. Like I said, once again, sometimes it's beyond your control. Most of the times it's on the municipality side, on the supply side. They've stolen the earth from the transformer, so there's no protection. Okay. All right, then I've put some relevant standards that's relevant to you guys. 1238, 10173. You guys are the experts on that. That's familiar to you guys? Okay, you know more about that. Those are relevant SANS codes. Probably there is more, but this is what I picked up on the internet. Okay, and in SANS10400, this is where I think I need to mention what that says. It's a building regulation, NBR, National Building Regulation, but it does involve air conditioning. Where there's artificial ventilation. In other words, if you go to a garage or a kitchen or something, there's no windows. A lot of flats or homes now you go to, because of space. Garages, I mean not the garages, the bathrooms don't have windows. Okay, the National Building Regulation says that you must have a separate switch for that extractor fan. You've got to have the extractor fan. Sometimes it's massive. I mean, you've got to get guys like yourselves to do the ducting and stuff. Sometimes it's massive, not just a normal extractor fan. Especially from a kitchen, there's no windows. You need to take it out. So it's normally air conditioning companies that do it. Now, in that area, there must be a separate switch, so that when you switch, some people just switch on the light, then the fan comes on. So they link it together. If there's no window, it's fine. But if there's a window, it's fine. But if there's no window, it must be on a separate switch. And it goes on further to say that after you've left the room, that fan must still run to remove the residual moisture. So how are you going to overcome that one? Not a timer. Pardon? Okay, the answer there would be an occupancy sensor. Okay. As soon as you walk in, it picks up body temperature. The light will there is a timer adjusting, there is a bit of a time, the fan will come on, and after you've left, the fan will still run for a few minutes. You can adjust whatever time it is. Okay.
But can you then dispose entirely with the switch or the manual switch? If you have the occupancy sensor inside the ear?
I guess so, yeah, but yeah, I guess so. Yeah. But unless it's education, you know, like I just did a block of flats now and I made a guy put occupancy sensors in all the flats. Some flats didn't have windows. So the one client says, but it's actually a nuisance. I switch it off because I don't like the sound of it. So I said to the contractor, you need to also speak to them and educate them and let them know why it's there and why it must just stay on. The switch must just stay on. Let the switch just stay on because it's going to pick up the body temperature when you move in. It's going to stay on, then when you leave, it will still stay on to remove all the residual moisture. Okay, because then you get infections in the lungs and that type of thing from the moisture. So it's very important, so it's health reasons. So he obviously didn't understand it himself, but I gave him the extract of that. It doesn't spell, it does say it must stay on for a little while. And the only thing I could think of is occupancy sensor. Nothing else I could think of. Okay. All right, I don't know how it affects you guys that do ducting and stuff and extractors, but just remember that for kitchens and bathrooms where there's no natural ventilation, there's artificial ventilation. PSCC, are we ready for time? Good? Okay. All right, PSCC. PSCC, it's the maximum short circuit current that a circuit breaker can carry before it explodes. PSCC is very important, especially in hazardous areas. Especially in hazardous areas where there's explosions. I've seen a video, I think it was from CBI. The guys had their switching suits on, they looked like spacemen, and when they go do switching, and downstream there was a fault. Even with their switching suits, both of them died and got burnt. So PSCC is very important. Generally, a normal installation, you can measure your PSCC with a meter, and it'll tell you what it is. Some guy phoned me and reckons, what should the reading be? I said, don't ask me that question, you should calculate it, you should do it. Okay. Generally, those instruments can only do up to about 100 amps. Anything over and above, you need to calculate it. There is graphs, there is consultants and engineers, they just use programs that be able to calculate it.
5KA seems to be a very general figure.
He's sounding like that gentleman and asked me, will 5KA be right? I said, don't ask me to commit myself, do the calculation. Okay, calculation is quite simple. PSCC is equal to V over root 3 ZT. Where ZT is equal to Z of the transformer plus Z of the conductors. Z of the transformer is equal to V squared all over P kVA times percentage impedance. Z of the conductors is equal to length into R squared plus X squared all over 1000. Okay, if we look at the table D1, okay, that's your table D1, which you'll get in the SANS book if you want to calculate PSCC. If you just got a normal, if it's under 100 amps, then you can use your meter. It'll be able to tell you what is the PSCC. And based on what the PSCC is, if it's, for instance, you do your calculation and your reading comes out to, let's say, 7 kVA, so your 5 kA is not going to work. Okay, so you have to calculate it. Okay. And based on that, you will determine, you will choose what circuit breaker to put in there with the appropriate KA rating. And that obviously goes with cost. So it's very important, don't guess. Some guys also, do you think a 10 KA will be okay? I reckon maybe an overrate. Calculate it. There's all the evidence there. Okay, if you look at, for instance, if you want to calculate Z of the conductor, you can choose a conductor, it's a bit, let's choose a conductor with a square, with a cross-sectional area of 35 mil. What is the corresponding R? 0.63. Corresponding reactance is, for 35 mil, is 0.52, if it's copper. Copper, aluminium, it's two different things. Then you can apply that. You have to know the length from point A to point B, from the transformer to the first dB, from the first dB to the second dB, and so on. Calculate the length. You must know the area. There's your resistance, reactance. Okay? This kVA rating is basically on the transformer. 315 kVA is the normal size that's used. This information will also be on the transformer. The percentage impedance will also be on the transformer. So everything is given to you. You must just memorize the formula. Okay, if you forget also, if you don't work with it every day, the formula is in the book as well. Okay, that's very important. Okay, cascaded system works hand in hand with PSCC. Okay, the first, if you do maybe the first dB, like from the transformer to the first dB, and you work it out, or from the first dB from the main dB to the first dB, you work out your PSCC is, let's say, it is 30 Ka. I don't know prices, I'm out of touch with prices. What will a 30 Ka cost, roughly? Okay, let's say 10,000 Rand. Okay, and it's a massive factory. Okay. So the consultant, generally they have programs where they'll calculate, or you can calculate it, but it's going to be a bit of time. Okay, the next dB, I don't need 10 Ka. I can go maybe 5 Ka. The next dB, 3 Ka, and so on. Downstream, you don't need to have such a high protection because it's costly, especially in a factory where there's lots of dBs. Okay, so this is where the consultant will work it out. He'll say, okay, I'm going to use CBI, and CBI is guaranteeing me that I will have the necessary protection downstream if I use their circuit breakers, and I could get away with using a less capacity circuit breaker. Okay, it's all about cost. This is what cascaded means. But on every dB, there'll be a big sign saying, do not replace any circuit breaker replace circuit breakers only with MNG or CBI, whatever it is. Don't go and put a chunt or whatever else because it's cheaper. That cascading system has been worked out based on CBI, for example, and you can only replace with CBI. But it's also law that every dB must be labeled to say do not replace circuit breakers other than with CBI. Okay, because the guarantee is coming from CBI. Power factor can either be leading or lagging. Ideally, our power factor must be as close as possible to unity. So that's when cos theta is equal to 1. 0.95, close to 1. Ideally, this is what your power factor should be. For obvious reasons. A low power factor costs the consumer more, causes strain on the supply cable, and penalties get imposed on the consumer. So it is in your interest or the factory's interest to make sure that power factor is brought to close as possible to unity. Cos theta is equal to 1. Okay. If you find your power factor maybe is lagging too much and you need to improve on it, you can add capacitors. And then it could be the other way around. Maybe your circuit. Generally in factories we have motors, just about in everything. Now it's changed a bit because we've got LED lights, but in those days they were fluorescent lights. Heavy inductive loads. And the heavy inductive loads do cause a lagging power factor. So we need to put in capacitors to compensate, to try and get our power factor closer to unity. Calculation of it can be done, maybe for another day. It's quite intense. Okay. If it's on the other hand now, and your motor is, your circuit now is too much overcapacitive, maybe too much capacitive. On the other hand, how do we improve that power factor? By the addition of synchronous motors. Okay. We can add synchronous motors to try and get the power factor to get close to unity.
What we normally find is a stop-start issue and then a starting inrush current, like when cooling fruit or whatever. And again, the question is, do we have to cater for it in our industry or must that be the electrical engineer's problem?
Inrush current is a problem. This is why municipalities always are on the supply side. If they know about inrush current in a factory, we normally put slow curve breakers and that type of thing. I don't know how you're going to overcome it. Because starters itself, motors itself, if you start delta starters, it starts off high and balances out. That's something that you need to work on. But it does cause a problem. Other thing that causes problems is all your VSDs also. Causes a problem with the harmonics and throws everything out. That's also something. That's also a problem. Okay, motors. Okay. Motors can either be connected in star or delta. I1, B1, C1, C2, A2, B2. Okay, those are your windings of your motor. 3 sets of windings. Okay, the beginning of the windings we call it 1, A1, B1, C1, and the ends we call it C2, A2, B2. A1, A2, B1, B2, C1, C2. Happy with that? Okay, we have a choice. Do we connect up the motor in star or do we connect it up in delta? Okay, later on we'll do the starters. Okay, if we want to connect it up in star, let's put a bridge piece across. There's your line 1, line 2, and line 3. On the other hand, if you've got A1, B1, C1, C2, A2, B2, okay, in delta, okay, that's the motor by itself, connected up either in star or delta. Now we'll need to incorporate. Oh, can I remove? Sorry, I'm just taking it off. You okay with it? Okay. First of all, we need to understand what mutual induction is. Mutual induction normally says that. Sorry. If we apply a little voltage there, let's say a millivoltage, take a core of a toilet paper, for instance, and take some insulated wires. On the one side, we refer to as the primary, and that's how we refer to as the secondary. And take a few turns there, few turns there of insulated wire, pass a little millivoltage there, and we put a little multimeter there. We will also get a millivoltage there. Absolutely no electrical connection between the two. All the energy from the primary linking with the secondary is done entirely magnetically. Okay, that's what mutual induction says. If you place two coils next to each other on the same core, they're expanding and collapsing. It expands, collapses, expands, collapses. The expanding and collapsing magnetic field on the primary will link with the secondary, and the magnetic field will be introduced into the secondary. So the transfer of energy from primary to secondary is done entirely magnetically. Okay, now let's discuss a motor. A motor consists of 3 sets of windings displaced at 120 degrees, electrical degrees apart. Each of these windings, when we energize the motor, each of these windings will carry equal amounts of current. This current flowing through the windings creates magnetic fields. The magnetic fields combine to form what we call a resultant flux, which moves around the stator frame at a constant speed. Okay. This rotating magnetic field links with the rotor, which is now the secondary, and a force is exerted onto the rotor, and the rotor will turn in the direction of the rotating magnetic field. That's how a motor works. If a motor is turning, the rotor is turning, you could grab the rotor and hold it, it will stop turning because there's no slip. Slip is necessary to develop a torque. What is slip? Slip is the relative difference between synchronous speed and rotor speed. Slip is necessary for the motor to be able to develop torque. So if you hold the armature or the rotor, the motor, you'll get hurt because that thing will be turning fast because of the torque. Okay, so here we have these 3 windings, each carrying currents. These currents create a magnetic field which rotates around the stator frame at a constant speed. The speed at which it is turning is referred to as synchronous speed. This rotating magnetic field will link with the rotor, which is secondary, and a force will be exerted onto the rotor, which will turn in the direction of the rotating magnetic field, and that's how the motor will turn. If the magnetic field is the other way, and it will turn the other way. Okay. All right, that's basically how a motor works, by pulsating rotating magnetic field. Now, star and delta. Okay, that's a good one.
That's usually a big problem.
Okay, here's your A1, B1, C1, C2, A2, B2. Okay, let's assume whichever. Here's your motor terminals here. Let's assume it's in star. Okay. Line 1, line 2, line 3. The motor is turning clockwise. If you want the motor to turn anti-clockwise, this is all we do. Either those two or those two. The motor will turn in the opposite direction. Okay, you've heard of a forward reverse starter? Okay, two contactors. One will be forward. Okay, instead of physically doing it, you'll use a starter, a forward reverse starter. Okay, yeah, that's right. Okay. This is basically the power circuit for a direct online starter. It's basically just a contactor with a coil and your overloads. You all have seen that in the field. It's a direct online starter. Control circuit will consist of a start button, first of all with a stop button, start with a retainer, maybe you can put the overload there. Happy with that? Familiar with that? That's what a direct online starter is. Press the start button, coil will energize, keeping that contact in, and the motor will stay on like that. That is the power. That is the control circuit. But today, guys use PLCs with a digital input and a digital output. Same thing. Okay, instead of pressing stop, start, you have a PLC and you program the PLC. Okay, that output there you'll have into the input will probably be a stop button. Sorry. You can put a stop button there. Other one will be a start button there. And then this will probably just go to the contactor. Okay, you'll program your PLC to do that. Direct online starter, generally for smaller motors. Okay, you have a no-volt coil. The purpose of the no-volt coil is power failure. The coil will de-energize. The motor will not start up automatically until you press the start button, for obvious reasons. Think of a bandsaw, for instance. You're working in a factory, press the start button, the machine, the motor's running, and suddenly there's load shedding. First thing the operator has to do, get a cloth, get a brush, start cleaning. They don't stand around, start talking about the weekend rugby or soccer, whatever it is. They got to work, clean their machines out. It's their time to do a bit of maintenance. Suddenly the power comes back on. Imagine if there was no under voltage protection. The guy was under the bandsaw, some machine, could get hurt. Okay, so that machine will not start up automatically until you physically press the start button, energize that coil, contactor comes in, motor runs. That could be controlled with a control circuit like that, or you could have, and yeah, you could add a whole lot of other safeties, proximity switches. You can add a whole lot of safeties on the control circuit, whatever else you want to add, other safety features. Okay, whatever is endless, what you can add on the control circuit. Or guys use today mainly PLC. Right. Question, those who have done N3, they always ask, are three-phase motors self-starting? Answer is yes, three-phase motors are self-starting because of the pulsating magnetic field. Okay. Are single-phase motors self-starting? The answer is no, because you have two windings, start winding, run winding. Okay, start winding, runs, cuts out, and the run winding comes in. But what creates that phase shift? By an addition of something external, a capacitor. The capacitor creates that phase shift, and by creating that phase shift, this is how the motor. So without a capacitor, the motor, when the motor capacitor packs up, it won't start. Okay, so they need to add something to the circuit to create that phase shift. And that's by addition of a capacitor to create that phase shift so that the motor can have a pulsating. So one now, 90 degrees, and the phase shift there would be 90 degrees. You need to create a phase shift to be able to have a rotating magnetic field. Be clear with that. So in the case of AC, we don't need anything else. The windings are there. We don't need to add capacitors to create phase shifts. AC is such that there is an angular displacement of 120 electrical degrees apart. So it is self-starting. Okay, then we can go on to, are we happy with direct online starter? Simple, eh? Okay, can we go on to, for reverse starter? You would need two contactors. Call that forward. Reverse. Okay. Okay, this is a power circuit. Press the start button, forward contactor comes in, the motor runs in the forward direction, whatever that is. Okay. Now we want the motor to not go in the forward, we want it to go in reverse. So you press the start button for the reverse. And this is what the power circuit will do. We know from the previous drawing that we need to swap. So the starter will do it. Okay, we've got line 1 there. We can take it there to line 1. Okay, we can take that one, it's line 2. We take it there. Okay, can you see what we've done? Forward, here's your line 1 comes there. Reverse, line 1 also goes there. and then in reverse, forward, line 2 goes there, okay, and then line 3 comes here in reverse, so it swaps it. Okay, again, you can have your PLC to do that. Forward, reverse. You program your PLC, inputs, stop, start, outputs. One output could go to your forward coil, and the other output code goes to your reverse coil. Okay.
You mentioned the PLC a few times now. Can you share with us, you find the more modern controls a lot more reliable than the old-fashioned mechanical ones, or don't you find any difference?
I think the younger guys work more with PLCs, eh? Grey-headed guys, we work with old hard wire and that type of thing. Exactly, yeah. But the younger guys are sharp. But I went on a PLC course in Durban with a youngster. I did it like a couple of years ago, but he was on another level with pneumatics and hydraulics. I said, sure, scary. So they need to be very sharp with computers, and you'll see how he handles the computer compared to how we handle it. So the young guys are very sharp. Some of them don't even have to be electricians, but they're good. They understand programming.
Do you find out there in the field that you get lots of PLC problems?
Oh yeah. I don't know, in your air conditioning, is that the case? A lot of PLCs?
Yeah.
In your air conditioning? Yeah. Even in the field out there, it's VSTs and PLCs. It's taken over.
But are they giving you more problems relatively?
I don't know. I haven't been in a factory for a couple of years now.
Okay.
Yeah.
And you still get called out to old mechanical stuff like
Yeah, you still get, yeah. You still need to know the basics.
Yeah.
You definitely need to know a direct online and to build on from there. From the direct online, we built onto a forward reverse because we understand what it does. Okay. Now we're going to go to star delta. We good with that? Okay, with that now we will need 3 contactors. Mains, star, and another contactor there. And then that'll be the delta contactor. Okay, there's something that I forgot to mention. Forward and reverse contactors, what did I leave out there? The overloads were there, the interlocking. Okay, sometimes it's mechanical, but you must also do electrical interlocking. Sometimes it's mechanically, you try to push one, other can't. But you also need to have, over and above that, you need to have the electrical interlocking. So when it's in forward, can't go in reverse. Okay, same thing here, we need the interlocking here for main, star, and delta. Again, we have line 1, line 2, and line 3. Okay, we need something, generally, okay, most of us old school guys used to work with starters where the operator had to sit and listen to the machine. Okay, if he was working on a lathe or a milling machine, he had to sit and listen. And then at a certain time he had 2 controls, start and run. So he had to sit and listen, and when the motor is running, it switches over. But what he was actually doing is, he had it in start and then star and then delta, but we were doing it manually. Even when we used to go for our trade tests, we were given a manual star delta starter. Okay, but it's basic. If you understand what a starter does, basically what it does is that it switches over to delta. We have it in delta, and then we switch it over manually by a lever, move it over to delta manually. Okay. Time went on. They removed the operator from switching. Maybe he falls asleep and he has it running too long in star. And so they introduced a timer, where a timer automatically will switch it in, motor will start in star, and then a timer will disconnect it from star and switch it over to delta. Okay. All right. Okay, we know what we want. We want A1, B1, C1, C2, A2, B2. Okay. Now we just have 3 sets of windings. The contactors are going to switch it over to star, and then when after a certain time, it must switch over to delta. The contactors must do it. Okay. Those are your overloads. Try and bring the overloads a bit lower. Sorry. Sorry, I haven't got it in proportion. Okay, it's not directly lining up, but we've got it there, right? That's the basic circuit. Now we want it to start, whether it's manually or automatically. Start in star. We have in star, just draw a little drawing in the corner. In star, we have that situation. Okay. Okay. All right. In this case here, no. Something's not right. Yeah. Okay, sorry. Okay. Yeah, C2, A2, B2. Is that correct? Okay. Here we've got our C2, A2, and B2 bridged. Okay. So when the motor comes into star, we've got C2, A2, and B2 bridged. Then when it switches over to delta, in delta now, what happens? We have line 1 goes to A1, A2. A2 will go to line 1. Okay. Then line 2 goes to B1 and A2. What is it? C2, sorry. That's C2. So we got A1, line 1 goes to A1 and C2. Line 2, B1 and A2. Line 2 goes to A2. And that'll be an obvious one. Line 3 goes to C1 and B2. P2 is that one. Okay. This all comes from this basic, what we want to happen. What happens, what do we want to install? We want C2, A2, and B2 to be bridged out, and then in delta we want that scenario. And that's it. Okay, that is your power circuit. Your control circuit, again, you could use PLCs. Stop and start on your input. Your outputs, one output will go to your main contactor coil, other one to your delta connector coil, other one to your star connector coil, and then your timer could either be, if it's an electrical timer, then you need to go to a timer coil as well. If it's a mechanical timer, it just fits normally as an auxiliary on top of the contactor. You guys worked with contactors and starters and stuff? Okay. All right. Try not to. Okay. But this is what it is basically, guys. This is the basic, those drawings that I did for you, star and delta. From then on, as long as you can understand what must happen in star, what must happen in delta, then you can play around. You can play around with it. Okay. And if you find that it's not going in the right direction, you can just maybe swap it on top there. Instead of blowing, it's sucking or something. That's the basic. Okay. The control circuit. 5 minutes. Okay, this control circuit. Can I draw the control circuit quickly? Okay, you all happy with that? Okay. We know what must happen. On the control circuit, we can have the overload there. We can have the stop button. Start. Okay, when you press the start button, the timer coil must energize. What else must be energized? The main contactor. It's auxiliary from the main contact. The main contactor must also come in, as well as the star contactor as well. Okay. That'll obviously have a normally closed timer. So when the coil energizes, the normally closed will pass current through the start, through the star. Star will energize. Then you could also have a the delta coil will also energize. So we have all these coils energizing. Press the start button, timer will energize, main contactor will energize, as well as that contactor was closed, so that star will energize. After some time, this guy will open, and that normally open timer will close, bringing in delta. To prevent the motor from starting in star and in delta, we put a interlock. That's the normally closed star, and here we will put a normally closed delta. Okay. Sometimes the interlock is mechanical. Over and above that, we use the electrical interlock.
Where would you use, because in our field we have thermostats, normally...
You can add it anywhere. You can add it in series, as long as it's in series. Your emergency stop.
Yeah, but it needs to monitor first through the controls. So there's coming a signal from somewhere.
Okay.
Where would you input that signal on?
Anywhere in series with the with this. It will normally close, yeah. Thermocouples, that type of thing. They all will be in series with the control circuits. You can put it there. You can even put it wherever you want it. You can put it even here. That's your line 1, let's say. The control circuit is normally 12 volts, 24 volts. Okay. And obviously these coils here will be 24 volts. Okay. So on this side here as well, you could even put whatever controls you want to add here. Thermocouples, whatever sensors you want, proximity switches, any other sensors, any other protection you want to add to it, you can just add it either there or you can have it there in series. Whatever your other controls are. You okay? Start L2 starters?
So if you have an overload situation.
Here's your overload will trip out.
But now the signal, say, in the plant room or whatever, it's called the mechanical overload.
Okay.
Any fans or too much done.
Okay.
How do we bring that mechanical overload signal? Where would we also bring it?
Just bring it in series. In series with that, yeah. All your controls, whatever sensors, safety sensors, whatever you have, put them all in series with that. One packs up, automatically kill the circuit until you find. Normally on your PLC, you'll be able to see on the screen, there's the problem there, there's the problem there. Okay. All right. I know it was a bit rush.